Welcome to today's lecture. This lecture is for Thursday. Today we're going to be moving into talking about functions. And so Tuesday's lecture was a little long, I think just clocked in a little bit over an hour. And so I'm going to shorten this one up just a little bit because I want to kind of limit the scope what I'm talking about to just the functions. These first two chapters, the content that we're covering is just some of the kind of laying out the basics behind, last on Tuesday we talked about naming, predominantly about naming, and this one's going to talk about functions and just general considerations for that. For the Dropbox, keep in mind Lab 2 will close on October 31st, so please get your submission in there. And then the Project 1, please take a look at that and let me know if you have any questions about what direction to head in there. So, with whatever time, additional time we don't have necessarily for the lecture, please use that to review those two things and make sure that, that you're on task. And if you have any questions, again, let me know so I can help clarify that. Moving into probably next week or so, we'll probably have generate another lab or so to work on. So you can anticipate seeing something next week there. All right, so to move into the content then, today we're primarily just going to focus on functions and how functions fit into our programs. Applications have evolved a lot, especially depending on who you've talked to. I've worked with developers that have been developing for 20, 30 years, and their style of coding can sometimes be very different than the style of coding that I'm used to, what I learned in college, and the way that I've been writing code ever since. To this day then, what we predominantly see is that functions are how we organize our programs. That's not always the case, but for the most part, functions are, as the author says, our first line of organization in any program. And we can look at a lot of different programs in order to figure this out. One benefit that we have, I think, as developers is this open source movement, and that is that it's only becoming more powerful. There's only becoming more and more code available on the internet. You go to a site like GitHub or Bitbucket. I tend to pick on GitHub just because I like it. But you go to a place like GitHub, and you can have you have the Linux kernel is available on GitHub. You can have projects that are sponsored by Google and Facebook on GitHub. You can have just any old person like me posting content and code on GitHub. And so we have this ability to go and look at this code, some of it written by really good developers, and study and learn from it. We'll take a look at this a little bit later, but here is the entire Linux kernel. So Linus Torvalds, not quite sure how he pronounces his name, but this is his repository, and this is the Linux kernel. The entire Linux kernel is available open source on GitHub. And so again, people that are doing some very, very talented programmers, we can go and look at their code in ways that we never could before. I guess we're here, so if we look at that, if we go to the base of the repository here, these are going to be all the files that make up Linux. We can just pick, I think, pretty much any old file, but I'm going to go back to the one I was just at because I know that it has the things I want to talk about. So if I pick the crypto folder and maybe this ahash.c file, okay, Linux is a lot of C files, a lot of C code. If we open that up, okay, what do we have inside this file? We have a file that's relatively long. It's probably going to be a couple of 200-300 lines of code, and inside of that we just have a bunch of function calls. Some long, some short, but that is the main organization of this class. And so opening this file up, and if I'm coming onto this project and I need to make, okay, 615 lines, okay, 493 lines of code. If I need to understand this, then this is how I start understanding this class. I open it up, I start kind of like I would any old novel or book from the top, and I start working my way down. And that's just if I'm trying to build understanding or context for this particular class. Now, as someone who maintains a lot of code, that's not typically what you do. Typically, you start somewhere in the application, and then you jump around from file to file, class to class, library to library, picking out the functions, following the function calls, and understanding just the functions that you need. So, there's a couple different ways we're going to need to look at how we structure that. Regardless, the basic structure for a lot of our programs is going to be the function itself. We can also take a look at, let's see if I can get it to pull up here, WordPress, just because we've been working with WordPress. And so if you look at, this is a WordPress site, Okay, if you look over here on the left, try to click it so that it triggers the little thing. It's organized. It's a bunch of files and folders. And if we look in the includes folder, that's where you're going to have a lot of the core files for the WordPress framework. Scroll down in there and you'll find this http.php file. And looking at that and just about any other file in here except maybe some of the class files, because those class files are going to be structured in actual classes or objects. What do we have? We just have hundreds of lines of functions. And a lot of these functions exhibit something that's important, something we'll talk about a little bit later, is that they're relatively short, they're relatively small, and it would appear, looking at just a few of them, that they do one thing. A lot of comments. Comments can be both good and bad. Definitely in an open framework like this, when I'm looking at functions, this sort of documentation does help me. But at the same time, this documentation does exist somewhere else. I can go to the documentation for the WordPress framework and find it completely hosted somewhere else. So I don't necessarily need all this documentation inside the code. But that's, I guess, documentation is a topic for another day here. But again, we just scroll through this, and what do we have? We just have several hundred lines, 500 and some odd lines of function definitions in this one file. Comment.php, same thing. Okay, there's a function, rather long one. Here's a rather short function. Functions in PHP are just defined with that function call. So they're the same concept, slightly different than C. We can go ahead and we can take a look at WordPress, or I mean Drupal. So Drupal's another relatively popular open source PHP-based framework. I have a stock Drupal website set up here. We haven't really studied the structure of Drupal, and that's fine. That's kind of beyond the scope here. All I want to point out is same thing with this. Okay, this first function here that we get, kind of a brutal guy. Function node help. He's got a lot. There's a lot of content in here. But once we move beyond that, we can see our functions start to shorten up a little bit. But again, overall basic structure of a lot of this framework is just like our WordPress, just like looking at some of those files in the Linux kernel. They're functions. So basic organization, basic structure. So some rules. They should be small. And so you want to keep them as small as possible and then make them even smaller than that. And the idea behind that is that functions should do one thing, and they should only do that one thing. And that the larger that a function gets, the more that that function can do. One of our main concerns with writing clean code is the maintenance of it. And not only other people, I almost said that other people maintaining it, but not only other people, but ourselves included. I think I mentioned earlier in the semester that if you haven't looked at your code for more than 6 months, then it's almost like looking at it again for the first time. And now whether or not it's 6 months, it's 4, maybe it's a year, it's hard to say, but we're not only concerned about others that have to maintain it, we're also worried about us that maintain it, because maybe we're a small shop. As a consultant or a freelancer, I write a lot of code that only I ever look at. And so it's very easy for me to get lax in my practices and start creating some really ugly multi 100-line functions. And I've done it, unfortunately. What I've noticed, though, that as I become more disciplined in my approach, that the more concise I make my functions, the more focused I make them, and ultimately I may end up making more functions, the cleaner my code is, the easier it is to read on a variety of levels. Functions should be obvious, should be transparently obvious. Looking at the function name. So depending on the language that you're working in, you typically have the return type, or in the case of PHP, just simply the function keyword, the function name itself, and then the arguments and the name and the type of the arguments, again, depending on the language. And so the totality of all of those pieces, it should make, just simply by looking at that function definition, we should have a pretty good idea of what that function is all about. What about blocks and indenting? Okay, the author recommends no more than 1 or 2 indents. And why does he recommend that? Well, that is to limit the amount of the scope of the function. Keep the scope small, keep it focused. If you're allowing your code to indent more than that, then you're allowing a lot of logic to nest. And it's possible that instead of having that continuous or nesting too deep into the function, that you can pull some of that logic out and call another function. And then that function can serve one purpose, and it can handle some of that code that would have then been indented. So we can limit the nesting. We want to keep the code relatively short, and then if we have to, we simply call another function. The names themselves, talked about that. They need to be descriptive and they need to be clear on the intent. And this just really can add to the code readability. Not only reading what that function is about to do, or what that function at least states that it does or pretends to do, but also when you're reading the code inside the function. You know, if the code inside the function is well written and well named, then it can also add a lot of clarity to reading that code. Okay, if we go back into the book, oh, forgot to scroll back up. 1 second here. Okay, so here it is. So this is a good listing, and I tried to find some examples in code I've written or seen, and it takes a while to track some of the stuff down. And so I'm going to stick with what the book has here, and that is, you know, the author challenges you to take a look at this code, and within 2 or 3 minutes, you know, can you tell what it does? And testable HTML. Okay, there's the name. The name doesn't really say a whole lot. We have some arguments, and then we have this long, lot of code. The author then went through and refactored it and turned it into this. And again, challenges you to take a look at this code and try to determine what it does. Now, we don't have to go into the details of what this code does. What we can look at is that what the author did was he looked at this code and found there is a lot of nesting. There is a lot of opportunity to take the code, the logic contained inside this function, and break it down further into additional functions. And that is what he did here. And so now, when we read this function, its scope is much more limited. It's a lot shorter. It's easier to read. It's more purposed. He renamed it, so now the name itself is more descriptive of what this function does. And so do these additional variables and functions that he defined, that he pulled out as he refactored this code. Include setup pages, include teardown pages. So, you know, so in the context of the system, and I'm not familiar actually with this system, this Nest system or whatever it is, it should be very clear that what these do. So now instead of having that big 20 or 30 or 40 line function that we looked at earlier, we have something cleaner that even the functions it calls helps add to the clarity of it. So maybe in reading this, I can understand what that function does without having to go and trace that function and read it and understand it. I've poked through some big applications in my time and had to follow, you know, the logical path of an application through many function calls. And some of those function calls, you know, you're jumping around the code and you get to a function that's 300 lines and it's got all sorts of ifs and different logical branches, and it can be time-consuming. It can be a daunting task to do that. And so keeping the size of your function short does really help with that. They should do one thing, and that one thing can be hard to determine. And so we talk about abstraction, and functions perform, you know, they take a level of abstraction and then perform that action. And so if we look at what does a function do, and we look at that's layers of abstraction that can help us determine if that function is in fact doing that one thing. If we look at this original function and we really got in here and studied all the different calls, we could see that it's going to operate at various levels of abstraction. And so we have some high-level stuff, such as getting the wiki page, or some mid-level stuff, all the way down to some low-level, where we're actually appending to the buffer. And so it gets confusing because it's hard to know exactly what is critical, what's not critical, and what is the purpose, the whole scope of this function within this system. When you're dealing with extraction, then, kind of a basic way of approaching it, or a way that can help you determine on whether or not your function is operating at the appropriate level, is if you can take the functionality from that function, take the code, and you can essentially pull out another function. And if that function doesn't have, if it essentially isn't the same name or the same functionality as that original function, then you could probably break it out, declare a new function, because it's probably dealing at a different level of abstraction than just that one deep that you want. Okay, so here's hopefully some better examples. I think the book does a pretty good job as well, so if I'm just completely killing it here, you know, read the chapter, make sure that you understand that as well to help, kind of reinforce this content, this material. Here we can see some different levels of abstraction. So get HTML, that's pretty high. We know that this function is getting HTML, but we don't know the inner workings of it. This next one is kind of mid-level, medium level, right? We have an actual string variable. We're assigning a value to it. We're calling another function, and so we're seeing a little more details of the implementation here than we are with just this high-level getHTML call. And then we have a very low level. We saw that in that last example of that function listing in 3-1. Dot append and a new line character. So now we're down in the weeds. We're actually implementing the details of the function by appending a new line for something. In this case, probably return for an output variable. This can confuse the intent. The level of abstraction that we're dealing with can confuse the intent. And so there's something called the step-down rule. And the idea behind the step-down rule is that the code reads like a narrative from top to down, from top to bottom. And that with each function that you define, the functions that follow it, just take that function and take it to a lower level of abstraction. And so if we had some, well, let's take a look at this example because I think this will help. So one method, one technique that the author suggests you can use is to create your functions like two paragraphs. This function is to include the setups and teardowns. We include the setups, then we include the test page content, and then we include the teardowns. To include the setups, we include the set setup if this is a suite, then we include the regular setup. To include the suite setup. Okay, and you can see this pattern that we follow. And so looking at our functions, putting them and stating them in this to format, then it reads like a story. We start high level, we do this, then we move to the next level, and this level adds another it goes down another layer deeper on what we did from the function or the step before it, and then we just keep doing that until eventually we've solved our problem. We've reached the level of abstraction, or reached the lowest. We're able to stop. As with names, okay, we talked about names in the last lecture, and it's just worth reiterating that the function names are no different. We want them to be descriptive because the function name is usually the first point of contact that we have with a function, and so being able to read that name and divine a very good idea what it's all about will help in our ability to read and maintain that code. A quote out of the book: "You know you are working on clean code when each routine turns out to be pretty much what you expected." And I think that's a great quote because if you read the function name, you look at the function, and there are no surprises, then it was a well-named function and it was a well-written function. When you read a function name and it really doesn't tell you what it's doing, and then you look at the function and it does nothing what you expected it to, then things are off, and the readability of the code could be improved upon as well as the overall function structure. Long descriptive is better than short enigmatic ones, and so I would never hesitate to have a long name. Function names, it's especially with a modern IDE. It's easy, it's easy to name these things. It's easy to refactor the code and change the name. It's easy to take a long name, and with autocomplete, we don't have to worry about typing out. I mean, I'm not saying I'm not proposing 50-character long function names, but it's easier to do because we have autocomplete. And so having a long name, I would take that over a shorter name because of the modern IDEs, the Visual Studios, the Eclipse that we can use that can make that easier, can facilitate our ability to use those. So please, I would take that, take advantage of that. And then I talked about that last one there. So refactor, it's easy to change. It's easy to open up a project in Visual Studio, define a function. Maybe you use that function. Maybe you have that function call in 15 different files at the point in time that you decide that it's not a good name and you want to name it, or you want to break that function down. It's easy to take that original name, change the function name, and just tell Visual Studio, okay, this used to be called this name, I now changed it to this. Go through every place in the code where that function was called and update the name automatically for me. It can do that. Visual Studio, Eclipse, they can do that, and that makes that job really easy. So you shouldn't hesitate to change names, especially as you start to use them in your program, in your code, because you might see that there is a better fit, or there is a better way to structure those functions. Arguments. And arguments, kind of like, it was a different shift when I first started writing function names. I thought big, cumbersome, complicated functions were good. I just thought it was really great to write these big functions that did all sorts of really cool stuff. And when I started thinking differently about that, my code got a lot better, but it kind of hit me that I was doing it completely wrong. Arguments are the same way. Now, I've never defined a lot of functions that have a lot of arguments, but the ideal number is 0, and then we only move up from there if we absolutely have to. Arguments, they can operate at different levels of abstraction, and that can cause confusion to the reader. And so, again, we're focused on writing maintainable code. And so when we confuse the reader, when we confuse the intent of the function, then it makes it harder to read that, understand that, and maintain that. Arguments can also make testing more difficult. If you have a function that has 0 arguments, then there's only one test that we have to run, and that's we call the function. If there's an argument that has multiple function that has multiple arguments, then we have to test every permutation of that function with all combinations of valid arguments if we want to thoroughly test that function. And so it becomes a lot more challenging in order to do that. Output arguments, they're typically hard to understand. And so what we typically see is that a function returns a value, accepts input through the arguments, and then it returns a value. That's not always the case, right? We can have functions that are, passed by reference, and so it accepts an object, it transforms that object or backs upon that object. It doesn't return anything because it was a pass by reference, and so that's not always the case. But we do have to be careful, and that typically if you're defining just normal pass by value arguments, it's not common to have one of those arguments, which I guess maybe would be passed by reference in that case then, but one of the arguments be an output argument. So just in general, be careful when you decide to use those, that your application of those does actually make sense. Okay, plague arguments, and if you read the chapter, you'll see your author is just adamantly against these, and I would echo that sentiment. Usually they're a relatively bad idea. Plague arguments are passing a Boolean as an argument. So whatever you're saying, that with this function call, this argument changes its behavior, and so that goes back to functions should be short and they should do one thing. And if you have a function argument that is a Boolean, you're saying, well, this function doesn't do one thing, it can do 2 things. And so looking at that logic, and more than likely being able to break out 2 function calls in order to keep the function short, keep it very specific. If you pass in an argument and it's true, it has one path of execution. If you pass in a Boolean and it's false, it has another. Now, that's not saying that you can't pass in Boolean arguments, but it's saying that the Boolean argument has an effect on what the function actually does. This isn't the same as a function that returns a Boolean, just so I'm being clear here. You can have a function that says something like is valid currency. It takes an argument that's maybe a double for money, and it returns whether or not that is true or false, whether or not that is whatever value provided here is actual valid currency. And you're going to see, or at least I see, a lot of functions like this when dealing with input validation. And all applications should deal with input validation. Here's an example. So what about using objects? Okay, we've talked about arguments just being simple values or primitives. What about complex, what about our objects? Well, you can look at arguments, and again, if you're starting to tread in that 2 or 3 or 4 arguments, then you need to look carefully at the function that you're defining. And maybe there's the potential, and this is, I think, a good example of that. Maybe there's a concept, there's some arguments that can be combined into another object. So if we look at this first version of this function, circle makes circle, we have double x, double y, and then double radius. Well, we could combine those first 2 arguments, and call it a point, and then call the value of that point argument center. So then it's clear we're dealing with the circle, we have a point, there's going to be an x, there's going to be a y, and there's a radius. And so now we've helped to eliminate that additional argument by encapsulating that inside of another object or structure or something. Functions should have no side effects. And what we mean by that, what I mean by that is that it should, our function should do one thing. and it should be clear based off of what that function is called and the arguments that it contains, what it's going to do. If it does more than that, more than what it's advertising that it's going to do, then it's having side effects, and we don't want to have side effects, because then you can introduce unexpected behavior in the application itself. If you look at this one, okay, there is an unexpected behavior. There is a side effect, and sometimes it's hard to see. With this one, we have check password. So check password, is password valid? You know, we could name this thing a variety of things, but the main purpose in just reading this alone, if I was reading this without knowing the source code yet, or the actual implementation of the function, I would expect it to compare a username and a password and tell me if it's correct or not. In this case, it does do that. Okay, we have this user object, and it gets the user by name as long as the user isn't null. So that means it finds a user from whatever data store it's pulling it out of. Then it gets the users encoded, get phrase encoded by password, decrypts the password. It checks if the valid password equals phrase. Okay, so this is just kind of this is just whatever way this function was implemented to check the password is correct. So we have a user, we have a valid password. And from there, then, this is the side effect. It initializes the session. So the idea is here that if you can only call check password when you want to initialize a session, and there are plenty of places in an application where we're going to want to check the password. Maybe it's change password functionality. Maybe we're just reprompting them to log in. Maybe they're accessing GitHub, and Amazon do this a lot. You know, I'm already authenticated into GitHub. I'm poking around the site, but all of a sudden I want to do something relatively administrative. I want to create an organization. I want to add somebody to an organization, to a repository, and then all of a sudden GitHub, it prompts me for my password again, just to make sure that it is me. And so initializing the session, in that case, once I've already have a session initialized, I don't want another one. I just want to check that I can provide them with a valid password. And so that limits now, it confuses this function a little bit because it's doing more than it should. Check password and initialize session would be a more appropriate function name for this function. So if you didn't read it, you might not expect this to be, the session to be initialized at this level. I would expect it to be initialized after the check password. I would have code that contained logic that said, okay, first we need to check the password. If the password is valid, if this returns true, then go ahead, initialize the session, and redirect the user to their home page or their dashboard or something. Otherwise, if it returns false, display that there was a login error. Don't repeat yourself. Look for code that repeats itself and try to minimize that. What we're trying to do is we're trying to eliminate the bloat in the code. Some of the easy things to look for in this case is just repeating logic. Do you see the same the same logic being repeated over and over, either within a function or throughout a code or a library or a class, a project? And if so, then try to eliminate that. Try to eliminate that and move it into a function of its own. That not only helps with the bloat in the code, but that helps with maintenance of it. Because if you have logic that's repeated over and over and over again, and you don't move that into a function, then when that logic has to change, you have to make sure that you find every instance where that logic is in order to update it. If you move it into a function, then you just change the function itself. And so it makes the maintenance, and it makes maintenance a lot easier, and it helps to reduce the likelihood that you're going to introduce a bug if you start changing or maintaining that code. Okay, and that's it. So that was a relatively straightforward chapter, I think relatively short here. Just like the last chapter, it just takes time. It takes practice. And one thing is to, constantly, it's kind of like writing a book and writing a novel, writing a paper, whatever. You write a function name, you start using it, and then you come back or you start using it throughout your code, and you realize that there's a better name, or that name isn't descriptive enough. And, again, don't hesitate to go back and change it to make it better. Don't constantly be, as you're writing new code, evaluating the code that's already been written to try to improve it and make it better. Don't just write it and move on. Write it, move on, but continue to evaluate it and make improvements on it. I think that was it. Well, here's an example. I don't know if this is maybe the most appropriate. So There's a lot of different places that we're going to write code. Not just in applications. We can also have a lot of application type logic stored in databases. And so in this case, here's an example of a stored procedure. And we're not going to study it, but if you watch me scroll, stored procedures are kind of like functions, and they should only do one thing. And if we look at this stored procedure, we can see here that we're at line 735 before we get to the end of it. That's with some comments and spacing and everything. And so that's a relatively large stored procedure. And so you may run across stuff like that, and that is a daunting thing to fix. And what oftentimes happens is, well, I don't have time to fix rewrite a 700, 800 line stored procedure or a 700, 800 line function, and so you just leave it and you keep working with it, and that can compound the issues, because now instead of fixing that function, instead of fixing that stored procedure, what you end up doing is you start adjusting your code to accommodate or handle how that code was written. And so sometimes then you don't have a choice. You start writing bad code because you have to do it in order to get it to work with the other. And so again, it can be a very difficult situation in determining when do you stop and rewrite that, or do you just keep going. But keep in mind that when you don't do that, issues like that can continue to cause, they can actually have an impact on how you're writing your code. And they can take that small, what may be a relatively small problem, it may be large at the time, but they can turn it into a much bigger problem as more and more code builds dependency on that troublesome code. So, okay, now that's it for today. So if you have any questions, please let me know. Shoot me an email. Otherwise, next week we'll continue to work on talking about clean code, and as I said at the beginning of the video here, we'll probably look at our next lab as well into the end of next week, or maybe even the beginning of that first week. I'd like to get one more lab in before we hit the holiday season, before we hit Thanksgiving, because once we get to Thanksgiving, then I don't want you guys to have to worry about anything really over Thanksgiving. But once we hit Thanksgiving, then we just have a week or two left, I think, and then we're into finals. So maybe get one in before and one more lab after that, and then come up with a final project or something. Maybe that'll be the last lab. I'm not sure yet, but I'll let you know, and we'll go from there. So hope you guys have a good weekend. Happy Halloween, and talk to you next week.